Hello students and welcome back to Mechanical Engineering Practice and Graphics. This week we resume in the chapters 5 and 6 of the book. We're going to go through the theme features, object properties, and creating reference geometries. But first, let's go and check the schedule of the semester. Last week we were supposed to have the first midterm. However, because of the winter storm that we had here in Texas, we have to move the exam for this week. So the midterm exam is going to be on Thursday, 24th. Sorry, 25th actually. That is next Thursday this week. Um, the files for the midterm exam are going to be available in Blackboard. If you go to Blackboard in the folder of the course, and then you go to content, you scroll down until you hit section 3 and 4, our sections, and then in week 5 there will be the midterm exam. This file is not available for you yet. It's going to be available for you in February 25th during all day. So the file will be available for you at first hour of the day, and then you will have the entire day to submit it to Blackboard. The exam is going to be due the same day at midnight. And to submit it, you go to content, and then where it says submit exam here, you will find the first one, midterm exam 1, and then you can submit your files here. Again, there are the system will allow multiple submissions, so if you make a mistake, you can just submit it again. As usual, no late submissions are allowed, so please have that in mind. And then for this week, we also have a homework number 4. So this week I'm gonna be covering the material of last week and this week. The good thing though is that last week we didn't have any homework. So for this week we only have one homework and the exam on Thursday. Now, as you already know, the lab has also a final project that is in groups. And every week, as you see here in the schedule, each one of you will be submitting one part for the final project to Blackboard. In total, each of you must submit 5 parts regarding the final project every week, as we have here in the schedule on the last column. For this week, what we're gonna do is we will have to form the groups, and I'm going to share this Excel example with you, where you're gonna place your names, as I have here, some basketball players, the phone number for each member, the respective email, in order for you to be able to contact each one of you, and also which platform are you gonna use, either GroupMe, WhatsApp, WeChat, Line, anyone that you want, but please have at least 3 different communication channels. This because since we have this virtual mode for the semester, I need that all of you must be able to communicate within each other. Now, the objective of the project is that you learn how to work with others as a design group. This is a design project, and pretty much in industry, things works pretty similar to what we're gonna do here. So that's very important for this week too. Remember, we have the exam on Thursday, the homework by Sunday, and also the Excel file with the contact information of your groups. There will be also a place for you to submit this in Blackboard, and I need to have all of this information available so I can know who is in which group. The rules for the final project are the following. The objective of the final project, the final group project is to model, assembly, and prepare the technical blueprints and design presentation. You can either do a poster or a PowerPoint presentation, and also a written report of a vehicle of any kind. The groups can be a minimum of 4 members or a maximum of 6 members. Each member must do 5 parts. So, for example, if your group has 5 members, then you will have to do at least 25 different parts. Remember that, like, if you, for example, do a wheel and then you use the wheel 4 times, it's only one part because you're only modeling one wheel. So you have to do a part that have different geometries that are essentially different. Each part must have at least 3 different features. So it's not enough to do like a circle and an extrusion to create a cylinder. It must be a little bit more complicated than that. And I will allow you to work with the students from sections 3 and 4, which are my sections. Uh, Please don't work with people from section 1 because Gia is their TA and she's gonna be the one grading them. So please just, if you want to be with students, either section 3 or 4, I'm okay with that. For the final presentation and poster, we will have one day to present this. The group will have to present either their presentation or their poster. It has to have the following parts: an abstract on why did you choose such vehicle, what was your inspiration. You will show also a concept drawing or blueprint, and I'm gonna show you an example of one in a moment. Um, so for this week, also have this concept drawing. It can be a handmade sketch, just the 3 standard views, front, top, and right, from your concept vehicle. So for me to know what are you gonna be doing during the semester. It doesn't have to have a lot of details. It doesn't have to have like all the dimensions. Just something general like the maximum height, the maximum depth, the maximum width, and that's it. Um, of course, you can modify this idea during the semester, but at least it will help me to see if you're aiming too high or too low. During the presentation, you will formulate the problem, or at least explain to us which were the problems that you faced during the modelation or the design of the vehicle. Either parts that needed to be uh, modified, because what we're gonna do is all of these different parts, we're gonna put them all together in an assembly, and we're gonna create some blueprints, from some technical blueprints from these parts and these assemblies. In the presentation, you will show also uh, the assembly. Uh, this is done also in SolidWorks. Uh, Also a render. We're gonna learn today how to render parts. And finally, you will finish with a conclusion. What would you have done different? How would you improve things in a design process like this? Please, it's very important for you to show the final assembly because this is like the final product of what you do in SolidWorks. The grading rubric is going to be the following. The presentation or poster is going to be 50%, and I'm going to focus on the quality of the presentation, the content, and the design, the clarity and coherence of information during the presentation, and if you have all the required components of the project that I'm requesting. Once you have finished the design, you will be, as I said, you will be submitting all the files to Blackboard. So what you're gonna be submitting is uh, each of the parts that you model, the assembly of all of those parts, and then you're gonna do two blueprints of those assemblies. One blueprint is gonna be with the technical views of the whole assembly, uh, the front, right, and top, an isometric view, the four standard views. And the second blueprint is gonna be an exploded final assembly with a balloon callout or and a list of materials. We will learn further in the semester how to do these blueprints and how to do the assembly. But for now, just focus on doing parts that can fit together. And the other 25% of the grade is gonna be the written report. I'm gonna submit a template to Blackboard. You just have to follow that template and answer all the questions that are over there. Um, my suggestion to you is to learn how to compress folders. Uh, it's the assemblies and the blueprints only in SolidWorks only work if the original part files are within the same folder. So what you're gonna be doing is you're gonna put all the files together in the same folder, and then you're gonna create a zip file. The zip file is just a compression of the folder where you have all of this information, and then you will submit in those compressed files to Blackboard. If you don't know how to compress a folder, here I have three examples for Windows users, Mac users, and Linux users on how to compress folders. So if you don't know how, you just go and check those videos. Please remember, if you don't submit all the required parts and all the files that I'm requesting, uh, some points will be deducted. So let's just avoid this by including all the information. Now I'm gonna show to you some examples of past final projects. For example, this group here, they tried to create their own robot, like a forklifter. Uh, as you see, I'm highlighting the final assembly along with the blueprint for that final assembly with the three standard views and the isometric view. This is a popular one. Many people have a bicycle in their home, and that's easy because you can actually go and measure all the components of the bicycle. So this is a very popular vehicle because it's easy if you have all the dimensions on what you're trying to replicate in the computer. In this one, they didn't have any dimension. They were just creating all the dimensions as they go through the design. But in the bicycle, it's easier since they have the real model. Um, this is an example of a toy train. I know that the blueprints for this toy train are available online. It has very few parts, like only 15 parts, but then you can be creative and try to create more parts that just fit within the model. So one suggestion is try to find blueprints online, something that has all the dimensions, and then you just have to produce the geometry in the computer. Something really nice to do is also to render your vehicle, and using simple geometries will save you a lot of work. So these people did the Tesla truck. Uh, they created this nice render from the inside, and they created all of these nice details, and they played with the lights and everything. Um, that's something that will add a lot to your project. This other group, they decided to do the poster, something easy, just some views of the final assembly. They did a fire truck. This is an example of the balloon uh, and the list of parts, the balloon call list. Um, these are just some examples of what you can do for the poster. Or for what you can do for the presentation, these people did a Mini Cooper, 1990 Mini Cooper. Uh, Here they have their inspiration, and as you see, the the concept and the final assembly were very similar. Also, along with the inspiration, and then they did for the blueprint in explosion. You see all of the components and all the parts that they use for the Mini Cooper. And as you see, the list of parts is not that long. They were like 2 or 3 students for this project. So being few students is not a good excuse. You can still do a very good work being few students. In a nutshell, my suggestions to you are find models with blueprints online, like for example the toy train. There are even YouTube tutorials on how to do vehicles, toy vehicles or complex vehicles. So also check those tutorials. Um, Ask questions in forums. If you don't know how to do something, for sure someone already did, uh, and and these forums are really helpful. There are communities that have free models available online, like GrabCAD. Uh, you can try to see some inspiration there, or maybe some parts that you can use. And and I guess the best suggestion is try simple geometries, but be very creative. As you see this toy airplane, the geometries are very simple, but then they use a lot of creativity to create something beautiful. So that's it for the final project. Remember this week to submit the Excel file with the information and the concept drawing, like this one here. I'm gonna zoom in there. As you see, it's just a piece of paper with a handmade drawing of what you're gonna be doing. Something very simple. Okay, with no further discussion on that, then I'm gonna move to our topic today. First of all, I'm gonna start by doing this extrusion, just a simple cube. So let's open SolidWorks, create a new file, and then in the front plane, I'm gonna create a new sketch, just a center rectangle there, whatever dimension is okay. And then we exit this sketch. And then in features, I'm gonna create a extrusion. Maybe I'm gonna increase the depth. But then what I wanted to show you here is that you can also create drafts, extrusions with drafts. And that will produce these transitions like this one over here. So I'm gonna apply a second direction there, like that. But then in the first direction, I'm gonna activate the draft by clicking this button here on the left. And then I can modify the angle of that draft. That will produce this kind of transition over there from a big square to a smaller square. And also that when you're doing these extrusions, you can also create a, thin features. So for example, I'm gonna create a new sketch, maybe another square like that. And then I'm gonna exit this sketch and create an extrusion from that sketch. But in this case, I'm gonna activate this button here that says thin feature. And then I can modify this thin feature. I can either switch the direction of that to make it outwards or inwards, like that. And I will create those thin features over there. So this is the thin feature that I just showed. And then you can do the same in revolutions, thin revolutions. So I'm gonna create maybe a new file to highlight that. In the front plane, I'm gonna create a new sketch. Like this. And then I'm gonna create a revolution using this axis as the center of the revolution. I'm gonna do only 3/4 of revolution in the other direction. And again, you can activate the theme feature option here. It can be outwards or it can be inwards. In this case, I'm gonna do it inwards. And you will see that it's a thin extrusion or a thin revolution around the axis that I used. Okay, uh, that's what I showed here. And then I'm gonna replicate the last homework that you did using this theme feature. I saw that some of you or most of you had problems with the relations in this part. So I'm gonna explain to you how to do this pulley. I'm gonna close these two parts without saving. I'm just gonna create a new file. Again, this is a tutorial. This will not be graded. The final homework is down in the bottom. Uh, we have a couple of tutorials today, so uh, it's good. It's nice if you uh, do the same as I'm doing in the video. If you try to do the same, because then you're gonna get familiar with all of these controls. Okay, using the front plane, I'm gonna create the sketch. Gonna create the center lines. Like that. And now I know that my origin is right there. Remember that in that homework, the origin was here in the center. So I'm gonna start by I'm gonna do only one half and then using the mirror entities to create the other half. So it would be something like this. And then I'm gonna be adding dimensions there. So the first one is this diameter here, 40. This one is 40. The way to add that dimension there is using the smart dimension. I click here in the axis and then in the line, and I can do only one half of the diameter or the entire diameter. So in this case, I'm gonna do the entire diameter with 40 millimeters. Again, I always use millimeters, gram, and second. Then this other diameter that is 108. If I want to do one half, I just move the mouse upwards. Or if I want to do the entire diameter, as you see here in below, we have the other line that is highlighting that I'm doing the full diameter. 108, and then this one is 70 here, like that. Okay, now this one is 53, and then we have this angle here of 65 degrees. So using this vertical line and then this diagonal line, I can place here my angle of 65 degrees, like that. And then I can continue with the drawing. As you see, I'm doing it very ugly because I want to show each step of the process. So here we have 30 millimeters. This one is 30 millimeters. And then we have this 360 for the diameter of the entire pulley. 360. And then we have this 17 here. Since this is a pulley and we know that a belt is going to be around the pulley, we know that all of these teeth has the same height, and that means that all of these horizontal lines are collinear and all of these horizontal lines in the top are also collinear. So 17 here from this valley to this top, 17 millimeters, like that. And then we have two of these mountains here. So I'm just gonna move this one here and here. So we're gonna do the second mountain here. Okay, now something important here is that I'm gonna add these relations here. These three lines are horizontal and collinear, all of those. And then these other two lines here are also horizontal and collinear. We will expect that this line here and this line here, these two, are parallel. Like that. And then the same for the ones at the other side. Okay. Now, we have here that this line is at 62 degrees from the horizontal. So let's do that. 62 degrees. And the same goes for this one. also note that this value here is 10 millimeters. Now, we will expect that all of these three lines in the bottom have the same length as the one in the center, since the belt is going to be a constant in that portion or in that length. So what I'm going to do here is that this one is 10, and then this point here and this line, they must be coincident, like that. But then I will have to move all of this a little bit. And this one is gonna be also 10, but the entire length. And then also the ones here on the edges must be also 10, because all of the ones that are in the bottom must be the same. So I can add another relation between this line and this other line. Not the point, sorry, I'm gonna delete this point, but the line. That they both are equal. That means that they both are the same length. So now this one that is 10, since these two are equal, the two purple lines, that makes this other line also 10. And then we have this total width of 160. Now, since we're assuming that the lines in the bottom are the same uh, length, the same happens in the top. The belt should have all of these valleys for the belt, or top of the mountain for the pulley. They must be the same length as well. So we can also add that relation over there. And as you see, everything is fully defined just by adding those relations there. Now we can do the mirror entities. Select all of these lines, or I can just select everything at once like this. And then use the mirror about this line, and I want to create a copy. So I have this activated. And then we can click OK. As you see, my sketch is fully defined. Everything is black. We have a close contour, and that's why we have dark gray inside. And then I can exit this sketch and create a revolution. For the axis of revolution, I'm going to use this line here, and then I only use 270 degrees, as it was supposed in the homework. Now, as you see in the preview, this will be exactly the same as you did in the homework, but in this case, we want to create a theme feature. So I'm gonna activate the theme feature here, and then I'm gonna click OK. That will produce exactly the same as we have here in the example. Okay. The next control that I'm going to show to you, this one is useful for when you see statics and solid mechanics course, because you will learn about the moments of inertia and the location of the centroid of a geometry or the mass and volume of a body. So we can go to evaluate in the evaluate tab, and we can see the mass properties of this part, and that will give me, assuming that the density is 0 grams, well, it will give me no mass. Um, we have here the volume and the surface area, the location of the center of mass. Uh, since we have only 3/4 of revolution, the center of mass is a little bit skewed. Then we have moments of inertia and some more helpful information. Uh, in the design of a pulley, this will be very important for avoiding vibrations, for example. Then we can also identify section properties. Let's suppose that I want to see this section. Okay, I'm gonna use this one here. And then using this face, we can find the centroid of that face, the area, also the inertia, and some more information for this face. So those two things are helpful when you are designing things to avoid vibrations. Uh, I just wanted to show you that you can have that here. And then I'm gonna do another tutorial. This time it's gonna be a multi-feature model. Uh, it's a little bit more complicated part. We have some extrusions and some holes. I'm gonna show you how to do holes within a part. So I'm gonna do it with holes. I guess it's easier, or at least I will show more of that. So this is the geometry. Again, this is a tutorial. This will not be graded. You just have to see how I'm doing this, and then if you can try to replicate, that would be great. And because you will learn how to do these more intricate parts. So let's begin. So here we have the front view, the top view, and the right view, along with the isometric view here on the left. Usually, you know that we have the isometric here, but uh, I guess I had more space here in the slide, so I'm just gonna leave it there. Um, let's begin with this square in the bottom, the big square. So I'm gonna create a new file, a new part, and using the top plane, I'm gonna create a new sketch. And in this one, I'm gonna create um, a center square over here. The dimensions for that square are gonna be, the total width is 140, and then the depth is gonna be 86 here. And I'm gonna extrude this body a total height of 18 millimeters, as we have here. Now, on this face, I'm gonna create a new sketch. And then I'm gonna create this hole here in the bottom that is 60 in width and 2 in height. So this one is 60 and only 2 in height. And then we have that it's at 15 millimeters from the back. So I'm gonna select this side and then this edge here, 15 millimeters. And then I'm gonna add a relation between this line and this bottom face, saying that both are collinear, and I will put the square down in the bottom. As you see, it's fully defined. I can exit now. And in this case, instead of creating an extrusion of that square in that face, I'm gonna create an extrusion to cut. And then I can cut either just a portion of the material, or I can go through all. We'll cut the entire material there and then click OK. And we have that cut. Then we also have these 4 circles here that we have here in the top view. One of them is hidden, and that's why we have these hidden lines. And the 4 circles have a diameter of 10 millimeters. Control 8. And then I just create 4 circles that are aligned like this. I can add a relation between them, saying that all of them are equal, so all of them have the same diameter, and then the diameter is 10 millimeters. Like that. Then we can say that the distance between the circles in the front are 110 millimeters from center to center. And then they are at 15 millimeters from this edge on the left, like this, 15. And then we have that they are at 20 from the front. Like that. And then 40 between them, 40 millimeters. Now, we have to add some more relations here. These two are horizontal. Also, these two are horizontal. And then this one and this one are vertical. And the same for the ones on the right. As you see, all of them are black because they have their positions defined and also their size. So we can exit now. Extrude cut. Again, I'm gonna just go through all. And that's it. We have those 4 circles over there. As you see, these holes go all the way through the material. And now I'm gonna create this back part. For that, I'm gonna use this plane here. I'm gonna create a sketch there. Control 8. I'm gonna do it again because I want it to be in the back, like that. Okay, I'm gonna start by defining these two big circles, the one that has diameter of 40 and the other one that has diameter of 50. One here, one around here. This one is 40 and this one is 50. Okay, and then I'm gonna draw a line from this corner to this circle, and then the same at the other side, from the corner to the circle. Now, this line and this circle are tangent, and also this line must be vertical, like that, and the same goes for the one on the right. These two are tangent, and then this line is vertical. We know this height is 56, so we can define that 56, and we also know this 118. Now, this relation I was from, this line is not vertical. As you see here, it's actually at a certain angle. So I can just click the relation and then click delete in the keyboard. And then I can move this one around. However, this other one that is tangent, that one holds. Here we have 118 from the bottom to the center. And then we have 50 from the center to this edge. Like that. And then we have this line here, this line here. This one is already tangent, as you see. This one is not, so we have to add that. And then this one is vertical. And then here we have an arc of radius equal 25. This arc here. So I'm gonna add here a fillet, this corner of radius 25, like that. We're almost done. We only need the two more circles here that has diameter 20 and 30. They are concentric, so this one is here and this one is here. This diameter is 20 and this other diameter is 30. And now I will close this loop here with a line, and then I'm gonna exit this sketch. Now as you see, we have here several closed loops, and I'm gonna start by extruding only the wall, an extrusion of 12 millimeters. So without having anything selected here on the left, I'm just gonna click extrude. Then I'm gonna select that sketch. And here, sorry, in the selected contour, I'm gonna select this part, only the wall. I'm gonna switch the direction, and the extrusion is only 12 millimeters. 12 millimeters, like that. You may think, okay, I lost the other two circles by only extruding this portion. But what I wanted to show here is using that same sketch that was used in the last extrusion. I can click there and then click in the extrusion button and select a different contour. For example, this circle here. Switch the direction, and this one that is in the bottom is 30 millimeters depth. And I can do the same for the other one. I can select this circle here, change the direction, and this one is 35. And that's how we have that geometry. So here, remember that I use faces from what I already created. Remember that first I created this box. It was just an extrusion. Then using this face on the right, we created that hole in the bottom. Then using this face in the top, we created those 4 circles that were 4 holes in the block. And then we created the sketch with the extrusion. And using the same sketch, we created those 2 circles, or those 2 cylinders. Okay, now I'm gonna move to this topic, creating a plane references. I'm quickly gonna create this geometry, and then we're gonna move to the planes. Okay, here we have 40, 10 at both sides. This one is 30. These two are the same length, so they both are equal and collinear and horizontal. This one here is 10, and this one is 40. And then we have 10 here as well. And then I'm gonna delete this line here, this one, and that one. Okay. This one is 10. And this one is 30. Okay, we have our geometry there, following these instructions. Again, this is just a tutorial. And then I'm gonna show you how to create axes and also planes. So for example, if I want or I need an axis that goes through this cylinder or this hole, we can go here in the features tab, go to reference geometry, and then click in axis. The axis can be the center of this cylinder, or we can also create axis between points. I will create this axis here, for example. We can also have planes, reference planes. For example, let's create a plane between this face and that face. I just click two faces and then it will recognize that I want the mid plane. And then I can create this plane, for example, for maybe to create a sketch there. Something like this. And then I can extrude that sketch like that. So I have something that it's like flying in the space. I can also create planes that are not like straight. I can use, for example, this line here and then maybe this corner point. And maybe there, I want to create something like this. So we can get crazy with these planes. You can create many different kinds of planes. And creating those planes will help you to create weird geometries and play around. Like not everything must be aligned with the X, Y, and Z coordinates. You can have something uh, like rotated in the space. Now I'm gonna create this revolution uh, using a cut. So we create a box of material, new part. In the top plane, I'm gonna create an extrusion, just a simple box. I'm gonna extrude that box like that. And then here in this phase, I'm gonna create a new sketch. Maybe maybe just a cylinder. Or let's try to create something more. more fun. Delete this line and this line. Okay, here what I'm gonna do now is I'm gonna exit this sketch, and this time instead of creating a revolution, I'm gonna create that revolve cut. It by default recognize that I'm using this axis here, but I just want, well, yeah, let's do the full revolution because it's a cut. And you will see that it created that weird geometry there. Now I'm gonna start showing you how to modify the appearance of this. I'm gonna click in edit appearance here in the top. I'm gonna select this face. And then I'm gonna create a surface. No, sorry, you right click here in this face and then click here in appearance. And then in this ball here, you can modify that one. I'm gonna use stone, some sort of paving there, maybe like that, or maybe asphalt. And we can modify the appearance of the entire brick. You can uh, modify just one face as well. If you just, I'm gonna do it again. You just right click here on the face, then in appearances. But here, instead of selecting the entire part, I'm gonna select only one face. So I'm gonna delete this. And here I'm gonna select this face. So once you have the face selected, then you can select the material. Let's see, maybe paint it like that, or maybe a rubber. Yeah, I like this one. So you can modify the appearance only of the face or the entire body. Um, so the way to do that is you just right click on the face, click here in appearance, click in this ball here, and then you can either select the entire part or just the face. So you can just delete the here, select one face, open here the appearance. That is this ball with circles here on the right. And then you can change the material. Let's use for that one maybe a glass. Clear glass. No. Maybe like this. And then we can see through there, through that material. We see the cut inside with that weird geometry and the cylinder of glass in the center. You can even import your own patterns or even figures. I was gonna do this tutorial, but I think the video is now too long. It's more than 1 hour. So maybe I'm gonna skip this or maybe for the next class. And now I'm gonna talk about the homework. The homework for this week is gonna be the same rules. It's due on Sunday midnight. No late submissions are allowed. Uh, Remember to submit the SolidWorks part file and the PDF with the screenshots of your progress. Use the file naming convention that we always use. Here is the three views, the standard views of the isometric that I want you to create. It's a very simple geometry. Uh, what you will have to submit is, of course, the entire body, not the sketches by themselves, the entire extrusion with. Uh, don't worry if the solid body is not showing any dimension as my, for example, as you see this file, this geometry that I did, it is not showing any dimension. I can just go and see how you created each of the sketches. So whenever I am grading your homeworks, I can go and open the sketches and see if they are fully defined, what dimensions did you use, what relations did you use. So don't worry if the entire body again is not showing any dimension. I want you to submit the entire body, like the one that is here on the top right. Use all of this information to create that, and then what you're gonna do is you're gonna create a render like this one. I didn't show you how to render that, so I'm gonna go back to maybe this part, and I'm gonna modify the appearance. So for this one, maybe I'm gonna use plastic, but not the part. Maybe just the operation, like that. And maybe for the holes, I'm gonna use a different material. Again, not the part, but the cuts. This one and this one. I'm gonna use a metal, gold. And then for this other one, I'm gonna use maybe a solid, no. Okay, why not? Maybe blue lead instead. For this one, maybe a fabric. And then for this one, I'm gonna create something different. So as you see, I'm using many different materials for each of these operations. And then, so I'm gonna save this part just to show you all the process. So in TA, Spring 2021, slides week 5. I'm gonna call this one render example. And then I'm gonna go to SolidWorks adds in. I'm gonna activate the photo view 360. And then I'm gonna go here to render tools. And I'm gonna create a final render. Maybe I'm gonna start with the preview window. Continue without camera or perspective. I'm gonna allow access. Okay. I'm gonna pause this render. I'm gonna modify this material because we have to red and red. So for this one, I'm gonna deactivate that and modify that appearance. Yeah, I like that one. Okay, so I'm gonna define the render size by clicking here in render region. I'm gonna create a preview window. So what the computer is doing, and you will see that your computer might speed up a little bit if you're running this in your local computer. Uh, so I think this one is okay. So I'm gonna create the final render, and I will open this render example. And it is playing with the lining and all, like the very realistic representation of this. So I'm gonna just, sorry. As you see, it is creating the render. I'm gonna increase the zoom a little bit. And then I'm gonna save this image. Again in the same folder, TA, slides, week 5, render example 1. And then if I go to that folder, you will see that I have here my render example. So that's what I want you to do. With the homework, just create the geometry, assign whatever material or color you want to each of the components of the geometry, and then create a render. So this time you will submit the SolidWorks part file the PDF with the screenshots, and also the final render for the homework. And on Thursday, I'm gonna submit the file for the exam. You will have the entire day. And please also remember to submit the list of the members of your group for the final project. Remember that we have a group meet chat. If you don't have a group to work with, you can just ask there, or maybe send an email to everyone in the course, or maybe just to me, and then I can try to find a group for you. Thank you very much, and see you next week.